Hi guys, welcome back to the channel. So this is what's going on chapter 6 chemical equilibrium by MNKML. So in this topic kita ada 3 subtopic: 6.1 dynamic equilibrium, 6.2 equilibrium constant, and 6.3 Le Chatelier's principle. So basically in dynamic equilibrium kita akan kenal pasti bahawa ada dua jenis reaction, iaitu irreversible reaction ataupun one way, and also the other one is reversible reaction yang boleh forward and boleh reverse. Okay, which means A menghasilkan CD, this one is reactant, this one is product. This is one way, and this one is product reactant, can either go this way or this way. Alright, kita ada dua jenis lagi, iaitu dynamic versus static equilibrium, in which kalau static equilibrium reaction stop at certain time bila sudah capai equilibrium, but dynamic equilibrium simply means reaction doesn't stop, but the rate of forward reaction is equal to the rate of reverse reaction. And the third one is chemical versus physical equilibrium. Physical equilibrium simply means dia hanya ada perubahan physical state ataupun phase, for example gas to liquid or liquid to gas. But then kalau chemical, selain daripada ada physical state punya perubahan, dia juga melibatkan new products form. Alright, the next part adalah kena tahu sketch the graph of concentration versus time, in which over time concentration of reactant akan berkurang sementara concentration of product akan naik, and after certain times dia akan capai equilibrium, so the concentration akan jadi constant, tidak berubah. And another parts of law of mass action, iaitu dia simply satu law yang menyatakan bahawa ratio of concentration of products, okay, to the reactants, okay, each raised to the power of its coefficient is actually equal to constant. For example, macam A menghasilkan B, B menghasilkan CD di sini, ada coefficient masing-masing, okay. So untuk C, concentration C to the power of C, coefficient dia, and then D to the power of D, okay, over dengan reactants punya to the power of the coefficient, that is called the equilibrium expression, which is the constant, okay, and this one only involves gas and aqueous only. Okay, and then kita selain daripada guna untuk Kc untuk concentration terms, kita juga boleh guna dia untuk Kp untuk pressure. And let me just remind you, this is the symbol for concentration. Alright, so kalau semua products and reactants kita adalah dalam satu phase yang sama, that is called homogeneous equilibria. Meanwhile, kalau kita punya reactants dan products in different phase ataupun different stats, so dia adalah heterogeneous equilibria. Equilibria simply means the plural of equilibrium. Alright. Okay, so you can have a look at 6.1 in details. So 6.2 pula, okay, oh by the way, okay, 6.1 juga mengaitkan bahawa Kp is equals to Kc RT to the power of delta N for gases compound. Okay, so delta N kita boleh cari menggunakan formula ini. You can have a look at the video in details. Okay, now 6.2 is basically selepas kita sudah belajar homogeneous heterogeneous equilibria, we will learn about the calculation. Okay, calculation dia kalau semua situasi sudah equilibrium, kita just express and calculate whatever yang kita mau calculate. Tapi kalau soalan dibagi dalam bentuk not equilibrium, kita kena guna ICE table, in which ada initial change in equilibrium table, and express the Kp or Kc and after calculate. And kita akan kaitkan juga dengan dissociation, percentage of dissociation. This is the formula, change over initial times 100. Okay, and then okay, untuk check sama direction sudah equilibrium ataupun belum, kita boleh menggunakan perbandingan Q versus K. Alright, so reaction quotient is basically equilibrium expression yang sama, cuma beza dia kalau K adalah untuk specific at equilibrium. Kalau belum equilibrium, kita panggil dia sebagai Q at any stage. So ada 3 situasi, you can have a look in the video. And then 6.3 Le Chatelier's principle simply means kalau sistem sudah equilibrium and kita kacau dia, the system will try to shift equilibrium position dia to reduce the effect of disturbance. So kita ada beberapa disturbance di sini, and you can have a look in the video on how to solve it based on these 3 key concepts: disturbance, system, and equilibrium, DSE. That's it basically for what's going on in chapter 6. Enjoy!